So I won't be solving all the questions, but I'll try to go over most of the questions and at least try to discuss the concepts being discussed. If you guys have a question there, Nyanmi, do please unmute and ask. It's really hard to keep track through the chat box and just like be interactive instead. Okay, so this is the first problem, and probably all of you have seen it before and seen the questions before. So just like take your time, look at the question, and then I'll begin. The key point in this question is that all the people here, the Americans, French, and the British, are distinct human beings. So even though there are three identities, we have to also account for the internal arrangement of these three identities. And it says that the same nationality must sit together. So for that, we'll have 3 factorial. And then since each person is different to the other person, we have the arrangement within each identity as 4 factorial, 3 factorial, and 3 factorial. If it was pretty simple, if someone has a question, do let me know. I'll just move on to the next problem. So you have to stop me if there is some question. For problem 2, I could come up with 2 approaches to this question. And the first one was through complementary rule, the one where we find out the total number possible, like total possible numbers we can have, and then subtract the possibilities where all digits are distinct and all digits are equal to one another. The second approach, which I will solve through here, is like the direct approach, where we have 3 digits, right? And then these 2 can be same, these 2 can be same, and then this one and this one can be same, right? So it's basically 3 choose 2, like these placeholders. For these placeholders, I write 3 choose 2, and then for the 2 placeholders that are chosen, for the first one we have 10 choices, then the second one would be limited to the first digit we choose, right? And then for the third choice, it has to be different since it says how many have exactly 2 equal digits. We can't have all 3 digits as same. So for the third digit, we have 9 options. And through basic counting principle, we are multiplying these 2. So जो भी इसका answer आएगा, that is going to be the answer. Okay, for problem 3, it gets trickier here. एक दफा पढ़ लो, like think about how you're gonna approach this problem, then I'll solve it. There are 2 levels to this problem. First one is that we have to, wait, let me, yeah. There are 2 levels to this problem. The first one would be of choosing the repairman, right? Abhi, don't think about the condition that there are going to be exactly 2 repairmen. Abhi, just think about all the possible arrangements. Then we can work towards the probability of choosing exactly 2 repairmen. So we have to select repairman, then we have to select televisions. So there are like 4 possible ways to repairing the 4 TV sets, right? We can have one repairman and he can fix all 4 TVs. Then we can have 2 repairmen and they can divide the 4 TVs among themselves. Then we can have 3 repairmen who can divide the TVs among themselves, and then 4 repairmen and each of them fixes 1 TV, right? Like, and for each case, we cannot not give a TV to 1 repairman. मतलब अगर हम 4 repairmen choose कर रहे हैं, we have to allot 1 TV to like each repairman. So we'll do this case by case, and then to find out the probability, we'll just consider the case given. In the case where we have 1 repairman, there are 4 possibilities, right? We can do 4 choose 1. Then in the case where we have 2, do 4 choose 2. अब आगे इन 2 लोगों को कैसे TVs मिलते हैं, we have to account for that arrangement as well. ऐसे हो सकता है कि for instance, let's call this A, let's call this B. ऐसे हो सकता है कि A को 8 मिले TV, and then automatically B would get 3 TV sets, right? And फिर ऐसे हो सकता है कि A को 2 मिले, and then the rest 2 वो B को मिल जाएंगे. And if A gets 3, then B automatically gets 1. So इधर हम इन बंदों की arrangement को देख रहे हैं, और इधर जो चूज किए हैं उनमें TVs किस तरह से डिवाइड हो रहे हैं उसको देख रहे हैं, right? First वाले केस में we had one person who was fixing all 4 TVs, so we didn't have to account for the arrangements of TVs, selections of TVs basically. And for the third case, we have to choose 3 repairmen out of 4. फिर इनके लिए ऐसा हो सकता है कि the first one gets 2 the second one gets 1 and फिर आखिर में एक ही बच जाएगा, or the first one gets 1, the second one gets 2, and then आखिर में एक ही बचेगा. Similarly, the third case would be this. Right? Again, this is how we.
Can you go through this again?
Yeah, एक सेकेंड में जरा पूरा सॉल्व करना, फिर मैं दोबारा से बताती हूँ. सही है? एक सेकेंड जरा guys. Actually, wait, let me explain the concept again. So we have 4 repairmen, right? And 4 TV sets. What the important part in this problem is that there are 2 levels to this, right? We can choose the repairman, and then for those repairmen, we have to assign the TV sets, right? Like for instance, I can choose मुझे इनको भी लेबल करने दो. So I can choose A only from these repairmen and then give that person. अभी आगे वाला part भूल जाके, what is the probability that exactly 2 of the repairmen are called. इस part को भूल जाओ. Just like think of all possible ways that these repairmen can fix the 4 TVs, right? I can choose one of them and tell him कि हाँ तुमने सारे TV sets सही करने हैं, right? That can be A, that can be B, that can be C or D, right? This is where I select only one repairman. That is the first case, जो कि मैंने यहाँ पे लिखा है. And then I can choose 2 of these repairmen, for instance, B and C, and tell B to fix like 3 of the TVs and tell C to fix 1 of the TVs, like the remaining 1, right? So उसके लिए, but that is like a very particular case. I have to consider all cases जिधर मैं 2 repairmen choose कर रही हूँ, and then I divide the TVs among them. ऐसे नहीं हो सकता कि if I choose A or B, तो उसमें मैं A को कोई TV ना दूं और B को सारे दे दूं, because वो तो first वाला case था हमारा. Second वाले में I choose like 2 repairmen, then divide the TVs among them. So there are 4 choose 2 ways to select 2 repairmen, and then ये जो brackets में ये वाला part है, these are the ways that I can divide the TVs among them. Was that Sajil जिसने पूछा था?
Yeah, okay, ठीक है.
You get it?
I get it. Yeah.
पक्की बात है ना?
Yeah.
And then अभी third wala case is where I select 3 out of these 4, and then these 4 men, and then give like TVs to them, and these are the 3 cases जो होंगे for the TVs. And the fourth case is that I select all of them, right? 4 choose 4, which is basically 1, and like that. And And then there's only like 4 factorial ways for the TVs to be chosen for the 4 men, right? Like, pehle, there are 4 possibilities to assign. Then there are 3 TVs, then there are 2 and then 1. These are all possible ways कि किस तरह से मैं divide कर सकती हूँ. What the question has asked us is the probability of selecting exactly 2 repairmen. So वही हम एक outcome पकड़ते हैं, like the outcome that they have asked us to consider, and then we divide it by all possible outcomes to get the probability for that particular outcome. इसका जो आंसर होगा, हम इन सब केसेस को ऐड करेंगे 4 choose 1 and then the 2 cases वाला केस, इसका आंसर ऐड करेंगे, फिर फोर्थ का आंसर ऐड करेंगे, the number we get that would be in the denominator, और फिर ये वाला जो है that would be in the numerator, and that's how you get the probability. Should I solve it or you guys can do it yourself? Saya? Okay, so for problem 4, you don't have to solve anything, you just have to give an argument, and note that for a second, let me try to write it decently. Notice that we are choosing I objects out of n objects, right? And in this part, we are choosing r minus I out of m. So essentially, हम total I plus r minus I choose कर रहे हैं out of n plus m objects for any value of I that is less than equal to r. It would go from I equals 0 to r, and we are choosing r objects out of n plus m objects. If you need to, actually, you guys should be able to elaborate this yourself, problem 4 में, but इससे ज़्यादा I'm not telling you for this question. अगर कोई मसला हुआ फिर भी तो like you can come discuss it later. I'll go over to the later problems जिनमें ज़्यादा मसला आने के chances हैं. Problem 5 में I'll do part A, and part B is exactly like that. So you should be able to relate this with binomial theorem formula. जिसका proof I think lecture 3 में sir ने कराया. Theorem says that, the formula says that Okay, realize करें कि it's like in एक second मैं लिख के लेती हूँ नीचे. It's actually pretty difficult. Yeah. अगर इनको और इनको match करें, you'll see that there is वाले expression में there is a term that is raised to power k, but there is not a term that is raised to power n minus k. और उसके लिए we can multiply it with 1 and raise it to power n minus k, and the two expressions would be equivalent. Or इसी तरह से this would be the first term and then this would be the second term, and 2 plus 1 can be raised to power n, and that's how you'll prove it. If this is like too easy for you guys and want to straight up skip to the later questions, do let me know. I think problem 6 में नहीं करूँगी. It's just binomial theorem. Problem 7 में we have to divide the 52 cards into 4 pairs such that each pair has 13 cards. तो उसके लिए we have two methods. या तो आप multinomial coefficient use कर सकते हो या फिर simply just do it with combinations. Multinomial से you have 52 choices, and then since you have to divide the 52 cards into 4 and each division carries 13 cards, we'll just do 13 factorial, 13 factorial. That is like one way to do this question. If you don't get how we are using multinomial coefficient here, do ask me that. Or another second way to do this question would be to choose 13 from 52, then from the remaining we'll select 13, then from the remaining we'll select 13, and eventually we'll be left with 13 cards. This is like one way to do this. This is the second way to do this. And by the way, I wouldn't be reading chat. I don't think there's anything there, but if there's something that needs to be explained, please ask me by unmuting. अच्छा ये भी I'll just tell you guys the concept. Use complementary rule in this question, I'd say, वरना सारा दिन लग जाएगा solve करते हुए. You will like पहले you select all cases, right? From the 20 elements, you have to choose 4, and then you'll subtract the case where none of these elements are considered in the subset. This is not interesting. So for part A, any teacher can be assigned to any school, right? there are really no restrictions at all. So for the first teacher, we have 4 possibilities. Then for the second teacher, we have 4 possibilities, and so on. In part B, we have to divide it in such a way, like we have to divide the 8 teachers in such a way that each school has 2 teachers. So again, when you have a big number and you have to divide it into multiple groups, then you use multinomial divisions. So yeah, and for that we will again do 8 choose 2. Right. Okay, so problem 10 was really easy. Problem 11 was easy as well, and so was actually अगर इनमें मस्ता हुआ तो you can ask me later. थोड़ी सी like we sometimes do silly mistakes in those kind of questions, but they're quite doable. If so, I'll just start with problem 13 now. Awesome.
Excuse me,
Yeah.
I just have a question.
Hmm.
It's related to problem 11. उसमें लाइसेंस प्लेट और उसकी बात हो रही है ना, लेटर्स और नंबर्स की। तो सर ने एक लेक्चर के अंदर कहा था कि अगर लाइसेंस प्लेट्स के अंदर ना नंबर्स में जीरोस और वंस यूज नहीं होते क्योंकि वो आईज और ओज से कंफ्यूजन क्रिएट करते हैं, तो हम नंबर्स का टोटल अमाउंट 8 लेंगे या 10 ही लेंगे?
10 ही
क्योंकि
लोगे
एक
आप।
अच्छा, चलें ठीक है, शुक्रिया।
सही। So for either for problem 13 मैं पढ़ लूँ सर। So we have to find the number of ways 8 people can leave the elevator. और ऐसे भी हो सकता है कि किसी एक फ्लोर पे nobody leaves and किसी पे like 2 निकल जाते हैं, but by the time we reach the 6th floor we have to have like the elevator completely discharged, right? So we can model this problem by the equation. Right. So I here tells us the number of floor. Basement floor 0 पे तो कोई निकलेगा नहीं because that's where we get all 8 people. अगर वहां से कोई निकल जाता that means we don't have 8 people. तो फिर first floor पे it depends कि कोई निकलता है नहीं निकलता, and this would simplify to. So each xi tells us the number of people that leave the elevator on the ith floor. We need to find the number of non-negative solutions to this equation, not the solutions themselves, but the number of solutions. And I say non-negative because again किसी फ्लोर पे ऐसे भी हो सकता है कि कोई भी ना निकले. और उसके लिए for these kind of equations सर ने आपको formula बताया था which he derived in the lecture. I think it was lecture 4. I don't remember वैसे, but yeah 3 या 4 में से कोई होगा. तो उसके लिए actually this is x, इधर x भी आना था. There are 6 floors. Yeah. Either we have n as 8, then r as 6, minus 1, choose 8. This is how you do part A. Up for part B, you'll separate the cases for, yeah, you'll separate the cases for men and women. एक second. Yeah, so the important thing to remember is that number of floors the same होंगे, part B maybe. So this part is going to remain the same. But जब आप for men or women separate cases consider करोगे, this would change. एक में 5 हो जाएगा और एक में 3 हो जाएगा. So you'll solve the two separately, the number of solutions for the two equations separately, and then use basic counting principle and multiply the two solutions you'll get, the number of solutions you'll get for each case. Agar end pe, if you need me to do it for you, I can elaborate, लेकिन आपको समझ आ जानी चाहिए. अगर आपको concept की समझ में आ गई है तो फिर आप part B भी कर सकते हैं. Problem 14 एक दफा देख लो, then I'll solve it. As the meeting is gonna end, so दोबारा से join कर लो ताकि दरमियान में cut ना हो. I'm gonna end this. आप दोबारा से ये वाला link join कर लेना. So I forgot to record second part of the meeting. I'm recording this again and I'll solve problem 14 in this recording. अगर आपको problem 14 की समझ में आ जाती है, you should be able to do problem 15 as well. So in this question, we have to divide $20,000 into 4 multiples of 1,000. And then there is also a condition on each investment. We can model this problem with this equation. Actually, since these variables are multiples of 1,000, we can just exclude that part and write this equation like this. And now these are no longer multiples of thousands, that they're just integers, and all of their sums should be, like, their sum should be positive integers, and their, in fact, non-negative integers, and their sum should be equal to 20. The restrictions we have on these variables are that x1 is greater than equal to 2, x2 is greater than equal to 2, and x3 is greater than equal to 3, x4 is greater than equal to 4. The trickiest part in this question is, how do we account for these restrictions? Like, either we invest in this opportunity, or if we do invest it, then it has to be greater than equal to 2, right? So remember how we use dummy variable yi in our derivation for non-negative solutions for these kind of equations. I think we covered that in lecture 4. So do look at it if you have not already, वरना इसकी समझ नहीं आएगी. We'll use a similar strategy here. It's not exactly the same, but it's quite similar. So we'll again use dummy variables. We'll use multiple dummy variables. Let's say y1 is equal to x1, y2. इस तरह से we will substitute these y's into our equations, and the equation would be this. In this way, we don't have to account for these restrictions. We can simply solve this equation for, not solve this equation, but like find non-negative solutions to this equation, because if x1 has to be greater than equal to 2, then y1 would automatically have to be greater than equal to 0, right? And similarly, y2 would have to be greater than equal to 0, and y3 would have to be greater than equal to 0. Like, for all y's, they have to be greater than equal to 0. And then we can find the number of non-negative solutions to this equation, which would be equivalent to the number of solutions to this equation with these particular restrictions. This is how we would solve part A. Now for part B, it says that the investments have to be made in at least 3 of the 4 opportunities, which means that we will consider cases where we invest in 3 opportunities out of the 4, and where we invest in all 4 opportunities, right? So we'll have wait, let's see how many cases. First wale mein, we'll have the case where we invest in the first opportunity, second opportunity, third opportunity, but we don't invest in the 4th opportunity, right? Wait a second. यहाँ पे, while substituting, we'll get a constant, which would be y1 के लिए it was 2, y2 के लिए it was 2. It would be, I think 7. Yeah. Then we have the second possibility where we invest in y1, y2, y4, and for that we'll have 8, and then you can like take this on the other side or फिर बाद में solve for it. Since it says at least 3 opportunities में हमने invest करना है, that also means we consider where we invest in all 4 opportunities, right? This is the equation from part A. We have considered all cases where at least where the money is being invested in at least 3 opportunities. We'll find the number of non-negative solutions to this equation, this equation, this equation, this, and this. And since either this can happen or this, or this, or this, or this, we'll add the answers we'll get for each equation. This is basic counting principle that we studied at the very beginning of this course. I did not tell you exactly how to find the non-negative solutions to these equations, because I assume that you watch the lectures, but let me just mention it for part A. The non-negative solutions, the number of non-negative solutions for this equation would be given by n plus r minus 1 choose n, which is basically n plus 4 minus 1 choose 9. In question 15, you'll model your problem in the same way you did in question 14. Each variable would tell you the number of fish caught for the particular type, right? And then you'll choose, you'll basically make 5 variables and equate their sum to 10. That's how you'll do part A. And in part B, since one variable for sure holds the value of 3, you would not consider the 5th variable. You'll equate the sum of your first 4 variables to 10 minus 3, which would be 7. So if you still have confusion in doing problem 15, feel free to email me. But I think question 14 should be helpful enough to solve question 15 as well. In part C of question 15, you'll use complementary rule where you'll use the sum of the 4 variables and equate it to 10 or 9 according to the case where one trout is being caught and where none of the trouts are being caught. It's all very conceptual, like agar ratta maroge to nahi hoga. If you understand the crux of all formulas and identities, तो फिर सारे questions हो जाएंगे. Like practice is a secondary thing. जब तक concepts clear नहीं होंगे, practice का खास फायदा नहीं है. I'm not saying that practice is not important, but consider it as a supplement for your grade instead of like relying on it completely. The more essential thing is conceptual learning. So do try to attempt all questions on your own. Pehle, and if you still have confusion, do email me. Also for problem 4, for actually problem 3, yes. I forgot to discuss the assumptions part. I solved the entire question for you, so you should be able to think about the assumptions. Think of it in terms of dependence and independence of the calls. Like, are they dependent on one another or are they independent? And think about each repairman being called, like the probability of each repairman being called. So that is it. If you have any confusion or want to discuss any particular part of any particular question, preferably post on Piazza or drop one of us an email or drop by during office hours.